Today we're working on tangent lines and implicit differentiation. So we have a problem here. The problem is find the equation of the tangent line to the curve at the given point. Now, what we don't have here is a y equals f of x. So y is not dependent on x. We have something of this form here. Okay, so we have to use implicit differentiation. So to do that is, I may just show you here. So I'm gonna make this for you here. So implicit differentiation, dy dx, for this one, you have two functions, the product of two functions. The first times the derivative of the second plus the derivative of the first times the second. So that's what we're gonna do with this one here. So let's start with this here, okay? And it's called implicit differentiation. So we're gonna go the first times the derivative of the second. Here's your chain rule. Plus the derivative of the first times the second. The next one, the first times the derivative of the second plus the derivative of the first, which is x, that function. Derivative of x is 1 times the derivative of the second. Derivative of a constant is just 0 equals 0 here. Okay? I'm going to combine the dy dx's. This one here should be y. Yeah? Sorry. So we have is the first times the derivative of the second plus the derivative of the first times the second. Plus the derivative of constant, derivative of a constant. Okay? So I'm gonna combine the dy dx's. So dy dx, this is 2x cubed y plus x is here equals to, I'm gonna bring this on this side, subtract y to this side, minus 3x squared y squared, and then I'm gonna divide to get the dy dx. So I'm gonna divide this by this here. So negative y minus 3x squared y squared 2x cubed y plus x. Okay, so now we have the derivative of that function. And use the correct notation here, dy dx. And this is negative 2 comma 1, negative 1 comma 2, and we're going to substitute into the derivative here. So y is 2, so negative 2 minus 3 negative 1 squared, y squared is 2 squared, okay, over 2 negative 1 cube, y is 2 plus x is negative 1. And then I'm going to simplify here. Negative 2, this is 4, this is 3, there's a positive here, negative 2, 4 and 3 is 12. Okay, so now this 2 and 2 is negative 4 plus negative 1. So this one you have negative 5 is at the bottom, negative 14 is at the top, 14 over 5. So your dy dx is the slope of your tangent line, and in point slope form it's y minus y1 equals m times x minus x1. Okay, so I'm going to put negative 2 comma 1 here, so it's y minus 2 equals 14 over 5 x minus negative 1. Simplify again, y minus 2 equals 14 over 5 x plus 1. So this here is the equation of your tangent line to the curve at negative 1 comma 2. And there you have it.